3 of statistics. Let's go ahead and actually answer some questions using the standard normal distribution. So let's read the question. Edith can run a 10K race, 6.2 miles, with a mean time of 55 and a standard deviation of 4. So the first thing I'm going to do is I'm going to label with my data numbers and with the corresponding z numbers below it. 4. 0, 1, 2, 3. It will easily allow me to compare the numbers. 43. Keep in mind that I do know a faster race time is actually better. So let's read our questions. What is the probability that she will run a 10K in less than 53 minutes? Okay, so the probability that Edith will run a 10K in less than 53 minutes. Well, 53 minutes is somewhere between -1 and 0. Means the empirical rule does not apply. And so I'm going to convert this to a z-score. Equals -0.5. We've just practiced with the table, so let's go ahead and look this up. And I'm going to sketch a picture here just to make sure this makes sense. Okay, here. Right, here's 0, 1. Seems reasonable that this is 0.0385. Okay, next question. What is the probability that she will run a 10K in longer than 60 minutes? So I'm going to go ahead and sketch 0, 1, 2, 3. Okay, so 60 looks like it is just past 1 standard deviation. Longer than 60 minutes. Okay, so I have the correct portion shaded. Now let's convert. The probability that x is more than 60, well, it's not a whole number standard deviation, so I'm going to convert to z-scores. Positive 1.25. Probability that z is more than 1.25. Now I can tell by looking at this that I can't find the number to the right, so I'm going to go ahead and find this number to the left. 1.25 is my z-score. Converts to 1 minus the probability less than 1.25. Now, I'm going to show you one more thing. I think because of the symmetry that this is also equal to z less than -1.25. Think of switching that diagram. They should both give you the same result. So let's go ahead. We're going to look up the yellow portion. 1.25. 1.25. 0.8944. Okay. 0.8944. Which means that, okay, 1 minus 0.8944, that we should get 0.1056 equals 0.1056. 1056. Now I'm going to go to the chart and I'm going to look up the negative z-score and I'm going to see if I actually get the same result here. Negative 1.25. Oh, there it is. The exact same number. Because of the symmetry in the chart, you can look up the negative and the positive, and it has a connection between them. What is the probability? The probability is 0.1056. Let's do the next one. What is the probability that she finishes between 50 and 60 minutes? The probability. Okay, now let's take a look. 50 and 60, so that is slightly below 1 and slightly above 1. All right. Well, let's convert to z-scores. So 50 negative 1.25. Okay. Now I've already converted the 60 from above. If I remember, okay, so I can find the pink, okay, the pink portion, which would be z less than 1.25 minus, cut out, the yellow portion. Okay. Now I actually have the numbers up here. So the pink number is 0.8944, and here the yellow section equals 0.7888. What's the probability? Okay. Edith ran a local 10K race. She finished the race in 52 minutes. What is her percentile? Okay. Assume the faster race time is the higher percentile. So I'm going to keep my diagram because it's going to help me answer this question. Okay, so we have 52 minutes, which puts me right, okay, 52 is right about here. Okay. Probability that X is, she finished the race in 52. Let's find this statement here. Okay. And that's going to correspond to this section. Now, I do need a z-score. So the probability that z negative 0.75. Okay? So let's look this up. Negative 0.75. $2,266. 0.2266. And I'm going to go ahead and find the yellow portion. Okay. 7734. Okay, now I'm going to look at this and let's label some numbers. So 55, 59, and over here, that was one standard deviation. So this mark was 52. Now, how many people did she finish faster than? Was it pink or yellow? She was faster than all the people in the yellow section here. Okay, so what was that percentile? So I'm going to take this, 7734, okay? This is the number of people she was faster than for the probability. 0.7734. I'm going to times it by 100 to make it a percent. 7734%. And then you round down. So what percentile? She was in the 77th percentile. Notice that asking a percentile is almost the same as asking probability. E, we are given the percentile. So the probability of Z less than some number is 0.8800 through 0.8899. There's the difference. Here you're given the Z-score or the data number. Here we're not, so we're going to have to work backwards. So let's go scan our chart for the minimum Z and the maximum Z. Okay, 8800. Let's be a positive Z-score. 8800. Here's an 88. Okay, 1.18. 1.18. 1.22. 1.18. 1.18. 1.22. Okay, so I have the Z-scores, but now I actually need the race times. Okay, so 1.18. Z-score formula says data minus the mean over the standard deviation. So let's go ahead and solve for the data number. 1.18 times 4 plus 55. Let's do the max, 1.22. So it looks like 59 minutes and some fraction of that next 60 seconds. Okay, if Edith was in the 95th percentile, 9500 through 0.9599. Okay, Z min, 95th. Oh, there's a 95. 95. Oh, there's a lot of 95s. 1.65. 1.75. 1.65. 1.75. Okay. Data minus okay, let's find our data. There you go. Now that we've practiced using the table, we're going to go ahead and look at some of the calculator buttons that can help look up these numbers for you. Keep in mind these answers that we have boxed on this page because we're going to be able to find them using our calculator. This is the last set before you can move on to some independent practice. Go ahead and find your calculator, and we're going to look at the screenshots here and where the buttons can be found. Calculating probabilities using the calculator. We have the second VARS, which is the distribution button. Okay, so it's right here. Second VARS. And then you see these two menus pop up. We have normal CDF. So we're going to be using number 2, and eventually we're going to be using number 3. Okay, so let's select number 2. Now most of us get this notation here, and there's a specific order that these things go in. The left x, the right x, the mean, and the standard deviation. Notice the notation here. Okay, mean with mu and sigma with standard deviation. What is the probability that she will run a 10K in less than 53 minutes? Okay, so if I am considering my diagram, my 55 is here, and 53 is here, and we're shading. The nice thing about the calculator is that you don't have to convert to z-scores. So we are looking for the probability that x is less than 53. Now, this number right here, -1e99. Okay, that's scientific notation. This is -1 times 10 to the 99th power. This represents negative infinity. Because if I'm looking at my chart, there is no left endpoint. There's only a right number. Okay? Think of this as negative infinity, x less than 53. Left x, right x. Okay, so let's type it in. I'm going to go ahead and clear mine so you can see where these buttons are. Okay, -1. E is right here above your comma. Right here above your comma. Second, comma, 99. Upper, 53. Mean, standard deviation. If you have an 83, it's going to look like this to start. Make sure you're separating with commas. Equals 0.3085. Go ahead and round to 4 digits here. Compare with the worksheet that you just did. 3085, yes. Okay, let's do question 2. Probability that she will run longer than 60 minutes. We have 55, 59, so 60 is here. Okay, probability that data is more than 60. Okay, notice that there's no right endpoint. So this is the probability, 60, less than x, less than positive infinity. This is left, this is right. Let's go ahead and enter. Okay, second vars, number 2. I'm going to clear it. Okay, left is 60, right is infinity, 1. Second comma for times 10. Okay. Mean standard deviation. Press enter. Okay. 0.01056. Notice this is the same answer that we got from the table. Okay. Between 50 and 60. Okay, so 50 and 60. Probability. Oh, left and right. Okay. Second vars. Normal CDF. Left, right, mean, standard deviation. 78870. 0.7887. Now this one looks off in that last digit because on the previous page we got 7888. Both answers will be accepted on the test or the quiz or a multiple choice exam. Okay, let's look at finding the data value from a percentile. Okay, so if Edith is in the 88th percentile, what's the fastest and slowest possible race time? Well, the first thing I know is that I'm trying to find the data number that would give me 0.8800 all the way through 0.8899. Now in this particular case, okay, I'm not going to be limited to the values in the chart. So we're going to press second distribution. And we're going to go inverse because we're going backwards. We're going from the probability number back to the data. Okay, so area. The area was 0.8800. Now, I don't want a z-score. I want my data numbers. So I'm going to go 55 and 4. 5969. Okay? 5969. And now I'm going to try for the maximum. Second vars. Inverse, because I'm starting with the area number. $5990. And we can compare this to the answers that we got on the last section and see how close we are. Okay, so let's check. So 88th percentile, so we got 5972, and here we got 5969 because we couldn't get quite to 8800. And here 5988 because our z-score was slightly off. Now, let's say that you really wanted a z-score. You could convert, or you could tell your calculator to look them up for you. So let's leave these two examples here, and let's see what we get. Second vars, inverse. Let's do 0, 0, and let's return z-score. So mean, standard deviation. If you pick a mean of 0 and a standard deviation of 1, automatically a z-score will be returned. Now notice that your calculator does more than 2 decimal places for a z-score, which is why these numbers are slightly different from the ones that you found in the table. The table is limited to 2 decimal places, whereas your calculator is not. Second vars. Let's check the maximum. Mean 0, standard deviation 1. 12259. And that's why your z-score is slightly more than the one listed here. We stopped at 22, and here we have 2259. You should be prepared to try the Delta Math questions or to work on any other practice worksheets to prepare for your quiz.